Yo, yo, what's up, geometry students? This is lesson 4.3. Can be found on these pages, and as always, make sure you're copying down these notes and have them ready by the due date. Here are our new terms for this lesson, so you should know at the end of this lesson, or at some point in between, I guess you could say, side, 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 what that means, and side, angle, side. These are postulates, so these are things we're going to assume are true. And then an included angle. What is an included angle? What is that? Make sure you know what that is at the end. And as always, read down there, check out that note, and make sure you use examples in your book, of course, for extra help with your assignment. Well, let's get started though. So at the top of your paper, please put this as your title, 4.3 notes. Proving triangles are congruent, and we're going to talk about what these things mean if it's possible. So I would say before, it seems like at least we've been doing things the hard way. So I see before we had to prove all 6 parts, all 6 angles, or all 6 corresponding parts, all 3 angles and all 3 sides had to match up in the triangle. So this guy, he seems to have found an easier way to do things. Maybe there's an easier way to do things. Maybe there's an easier way to prove that triangles are congruent. I'm not saying there is, but I'm saying maybe there is. So let's write this down first of all. Before, what did we do? We had to prove all 6 corresponding parts. All 6 corresponding parts were congruent to prove congruent triangles. So in other words, all 3 angles and all 3 sides. So write that down for me. You don't have to draw this incredible picture, but that's just kind of to help you hopefully start thinking about this. Is there an easier way? We always want to ask that in math or anything. Is there an easier way to get the same job done? If there is, why not do it the easier way? So that's my big question here. Is there a better or an easier way? Is there an easier way? So it sure seems like there should be. If we've got to prove all 6 parts match up every single time in triangles, that just seems like it's going to get kind of tedious. And it seems like, for instance, maybe something like this. So we're going to explore this idea of side, side, side right here. This, I don't want you to copy this down. I just want you to watch for the next couple minutes here as I kind of maneuver things around. So pretend you could come up with your own thing like this. You could cut out some pieces of paper, maybe get some sticks, and make sure they're all congruent like this. So when I drew these, the blue one, they're exactly the same. I literally copied and pasted the blue one, the red one, the red one, the green one, and the green one. So these things have to match up if you're going to do this. And I'm just going to move some stuff around here. Am I allowed to rotate things? Yes. Am I allowed to make the parts bigger or smaller though? No. So I am not going to be doing that. I'm just going to be rotating the parts here. So I'm first of all just coming up with one triangle down or over here. So I'm going to move this around, and I'm going to make sure this is as precise as I can be. Okay, so that looks like it's touching just perfectly right there. I am going to have to rotate this a little more because this green part in here needs to connect the red and the blue part. So remember, I can't just make it bigger or smaller. These have to stay the same. So I'm going to rotate this around a little bit more so that this gets a little closer to that. Okay, let me rotate this green one. I'm starting to think they're going to come together a little better here. If you have sticks or toothpicks or something like that, this works a little bit easier than what I'm doing here, but I think this is really valuable to see something like this being done. Okay, so this getting real close now, and I just need to rotate this a little bit more, it looks like, and just slide it down just a little bit. Again, not changing any of the lengths. Alright, that looks like a really good triangle to me right there. So this is one way I could draw a triangle given 3 sides that are that length. So let me see if I can make a different triangle with the same 3 sides. If I can, then this would not be a shortcut for us. But if I cannot, then I could say that if I just had 3 congruent sides in each triangle, that they would have to match up. So let me move that. Let's go with that. Let's see how close that gets us. This looks like it needs to be rotated a little bit here. Move down a little bit here, so I'm getting close. This, I'll rotate this just a little bit. And slide this over now. Alright, super close now. Let's just rotate the red one just slightly. Move that there. Almost. Yeah, I'm feeling pretty good about this now. And okay, that looks pretty darn good to me. That looks like a really nice triangle. Now, is this one different than this one? Is this one the same? That's the question here. Are these congruent or are they not necessarily congruent? So I'm going to pick this one up completely. I'm going to move it over here. See what we got. So does this match up? Well, am I allowed to rotate it? Sure, I'm allowed to rotate it. That's fine. So if I rotate this, what do you notice? Are these the same? They sure are. So it's not super duper perfect because I had a little bit of error there with my vertices, this not coming together in quite exactly the same way as that. But I think you can tell that, yeah, those two are definitely congruent to each other. There's no way around that. So I could flip this over, I could rotate it as much as I wanted to, but then if I flip it back and get back to where I started, they have to be congruent. These sides, these things have to match up. So I want you at this point to draw two triangles like this, and we're going to write down this as our postulate. So this is you don't have to write the word side, so you can just write SSS. And you could write congruence postulate. I'm going to leave that out though. So we're just going to refer to it in this class as SSS. If you want to know what postulate is this, Mr. Wagner, this is postulate 19. We've already had 19 postulates in this book. Postulates, remember, are just things that we assume to be true without proving them. So we're just going to assume this is true, but we kind of explored the idea here and saw that intuitively that makes sense, that this is the only way to do that. If you have three sides matching up, there's no way to draw a different triangle, in other words. They have to be congruent to each other. So the theorem, the postulate, sorry, says that if three sides in one triangle are congruent to three sides in another, the triangles are congruent. They must be congruent. So the triangles are congruent. So if I were to put tick marks up here, let's do that at this point. So that one would match up with that one. That was the way it had to be. It had to be rigid. These things could not be changing in length. I said you had to start off with three congruent sides. You could pick up those sides and kind of move them and rotate them any way you wanted to, but there's no way around it. If this is true and this is true over here, if they match up like that, this triangle has to be congruent to this triangle. So let's do a brief example dealing with that. I'm going to give these letters, or these vertices, some labels like this, K, L, and M. And let's say this is N, P, and I'm going to say that this one matches up with this one with this one, and this one, that one with that one. All right, KLM and NMP. What's the congruent statement here? What matches up here with what over here? Well, this is triangle KLM. We'll put it in that order to start. If you had to write a congruent statement, you would say triangle KLM is congruent to K matches up with N. L in this triangle matches up with P in this triangle. And then M in this triangle, the left one, matches up with P in the right one. So this would be the congruent statement. And why would this be true? Before we had to prove all 6 parts matched up. So we got the 3 sides, but before we had to say, well, this angle, this one, this one, this one, and this one. But now that we have this side congruence postulate, we can say that if this is true, if we have a picture like this where the 3 sides match up, then we can automatically assume that the angles are going to match up too. We can say that by the side congruence postulate, or just simply say SSS, and that is totally sufficient. So this is true by side. Alright, now let's explore that other one in this lesson. So here, side, angle, side. What do I mean by this? And what is this green angle? Well, we talked about, or we had mentioned briefly in the vocab, there was something called an included angle. This is an example of an included angle right here. This green part right here, this is an included angle. Notice how it's included between, or kind of connecting these two sides. The blue one here, I'm saying, matches up with the blue one here. The green one here matches up with the green angle here, and then the red matches up with the red. When I took this, I just copied and pasted it and kind of moved it around a little bit to get this other part over here. So is it possible, if this is true, if this is rigid, there's no changing the length here, no changing the length here, no changing the angle here, these three things have to match up with these three things. Is it possible for this triangle that I'm going to make to be any different from this triangle over here? Well, let me use orange, and I'll connect these here. That's not orange. Right, so I'm going to say this would have to fall into place like that, and this one, make that a little more perfect, because if it's not perfect, you might not see it as well, or see how it lines up as well. Okay, so that looks pretty darn good to me right there. So that had to be true. That had to be the third side. There was no way to make that different over here. There's no way to make that any different over here, because this is rigid, remember, not able to scrunch that in at all. It has to stay like that. So let's see. Did I make a new triangle? Well, let me rotate this around a little bit and move this over here. And I'll slide this over here. Well, look at that. Uh-oh. It seems like it's a new triangle to me, Mr. Wagner. Hold on. Hold your horses. Hold the phone there. Remember, I can, in a sense, if I were doing this on with like a cutout triangle, it would be as if I'm going to pick it up and flip it over. So I'm going to transform it in that way. I'm going to pick this up in a sense and flip it over. I'm going to flip it in the, I'll go with the y-axis there. So I'll flip that over now. I picked it up and flipped it over. I want to rotate this now, and oh, maybe now you're seeing it. So that was okay, that was allowed. I can pick it up, flip it over, rotate that a little bit more. Does this line up perfectly with that? It sure does. So that is a postulate for us, a postulate. We're not going to prove this is true. So we're saying side, angle, side works. I'll flip that. I'll just rotate that around a little bit. Alright, and I'll rotate this one around a little bit. So at this point, now we can write down our other, this being a postulate for this lesson. We can write that down. So we're going to think of this just like we did over here. So let's just write down SAS. If you wanted to say side, angle, side, congruence, postulate, okay. Just say SAS though, and you'll be just as good. So SAS, postulate 20. Alright, and what does that say? Well, it says in a similar way to what we had over here for the side, side, side. But now this one says if two sides, and it's not any old angle, but it has to be that included angle. It has to be that included angle. If two sides and an included angle in one triangle are congruent to two sides and an included angle let me use the symbol there for angle, an included angle in another, the triangles are congruent. So up here, what had to match up to start? What was I saying had to match up? This right here had to match up with this right here. That green angle had to match up with the green angle. So that's already labeled there well. And then the red one had to match up with the red one here. The orange parts did not have to be, the orange sides didn't have to be congruent to start. But now if they were, if this were true and this were true, we would know then that this and this do match up. In fact, we would know that this angle and this angle also match up, and then that this one and this one all match up. So if we have these three parts matching up with these three parts here, we can actually assume that all 6 parts would match up based on that. So let's do a final example here. This one we're going to do a short proof to finish up these set of notes here. So let's do this in black, make a vertical line here for that, make a horizontal line for there. Okay, and this will be my statements and my reasons. And I'm going to give you some stuff in the picture. So let's write down our given part up here. What's going to be given? Well, look at the picture. I'm going to write some stuff in here. So I'm going to say that this and this match up. And I'm going to call that M, T, H, and A. Do you see the word I spelled there? If you put all 4 letters together? One of my favorite words in the world. Oh yeah. Math. Oh yeah. So let's see what else we got here. We're going to say that this angle matches up with this angle right here as well. So for the given part, what's given in the picture? What did I actually draw in there? I said that MA, segment MA is congruent to segment HA. And I also told you that angle, if you look at this angle right here, we can't just say angle A because there's different angles coming out of angle A. So I would say MAT, angle MAT, is congruent to angle HAT. And what are we going to try to prove? Well, a lot of this chapter, this is what we're doing in this chapter quite a bit. We're trying to prove the 2 triangles are congruent. We're trying to here prove an MAT. Would that be a correct correspondence? MAT to HAT? Would they match up in the same way? It sure looks like it. So HAT here, MAT here. That looks like the correct congruence statement, or how that would be written. So HAT. We're going to try to prove that's true. So step 1, always our given step here. So I'm just going to write given, and I'm going to write down, just say see above. So we've already got that written down up here. I'm not going to rewrite it. So this stuff is given to you. Well, what else in this picture? So this one looks like I can't say this side's congruent to this side. I don't have any information that would lead me to believe that's necessarily true to start. I've got this side and this side. I've got this angle and this angle. Well, don't they share AT? Don't both triangles have that in common? Yeah, sure. So let's put that, let's use, I'll go with orange for this one. I'll say this, in a sense, is the same in both triangles. AT is the same in MAT as it is in HAT over here. So this property, we don't use this all that often, but this is where it actually, I think, is beneficial to say here that we have TA is congruent to itself. And why would that be? Well, why would something be equal or congruent to itself? That's the reflexive property. So this is the reflexive property. So we actually do use the reflexive property a good deal in this chapter when we have these sides that are being shared by the 2 triangles or the 2 figures in question. We can say that's true. Now, you might be amazed by this. This is only a 3-step proof. We're actually there. We're done. We're going to say that triangle MAT is congruent to triangle HAT. Now, why can I say that? Why are we done? Well, isn't this just side angle and a side here matching up with a side angle and a side here? And we just said that if that were true, postulate 20, side angle side, if that's true, the included angle, is it the included angle? Yep, it's the included angle. It's the side, or the angle that they have here and here, between the 2 sides here and here. So this is it. I can just say side, angle, side. And so that'll do it for us for this lesson. Hopefully you found that helpful. And let me know if you have any questions in class. We'll go over some problems together in class. And hopefully this will help you with your homework problems too, for those that are assigned to you. So have a great day, everybody, and I will see you later.